Welcome back to Operating Systems Crashcast. I'm Victor, and with me as always is the brilliant Sheila. Today we're diving into Chapter 7 of our journey through Deadlocks, specifically focusing on Section 7.1, System Model. Sheila, why don't you kick us off with an overview of what a system model is in the context of Deadlocks?
Absolutely, Victor. A system model in the context of Deadlocks is essentially a simplified representation of how processes and resources interact within an operating system. It's like creating a miniature version of the OS world to help us understand and analyze potential deadlock situations. This model is crucial because it allows us to study deadlocks without getting lost in the complexities of a full-scale operating system.
That's a great explanation, Sheila. So, it's like creating a sandbox where we can play out different scenarios involving processes and resources. Speaking of which, could you break down the main components of this system model for our listeners?
Certainly. The system model primarily consists of two main components, processes and resources. Processes are active entities that request and use resources to complete their tasks. Resources, on the other hand, are passive entities that are requested, used, and released by processes. These resources can be hardware devices, data structures, or even CPU time slices.
Interesting. So it's like a restaurant where processes are the diners and resources are the tables and utensils they need to eat. Now, I've heard that resources can be categorized into different types. Can you elaborate on that?
Absolutely, Victor. Resources are typically classified into two main categories, reusable and consumable resources. Reusable resources are those that can be used by a process and then released for use by other processes without depleting. Examples include CPU cycles, memory, and I/O devices. Consumable resources, on the other hand, are created and destroyed during system operation. These might include interrupts, signals, or messages.
That's a crucial distinction. So, in our restaurant analogy, reusable resources would be like tables and chairs that can be used by different diners throughout the day, while consumable resources might be like the food itself, which is created and consumed during the meal. Now, how do processes actually acquire and release these resources?
Great question, Victor. Resource acquisition and release are fundamental operations in our system model. When a process needs a resource, it requests it from the operating system. If the resource is available, the OS allocates it to the process. Once the process is done using the resource, it releases it back to the system, making it available for other processes. It's important to note that a process must acquire a resource before using it and must release it after use.
That makes sense. It's like how diners need to be seated at a table before they can eat and should leave the table when they're done so others can use it. Now, I've heard about something called a resource allocation graph. How does that fit into our system model?
The resource allocation graph is a powerful tool used to visualize the state of a system in terms of its processes and resources. It's a directed graph where processes are represented as circles and resources as squares. Edges in the graph show which processes are holding or requesting which resources. This graph helps us identify potential deadlock situations by revealing circular weight conditions.
That sounds really useful. So, it's like having a bird's-eye view of our restaurant, showing which diners are occupying which tables and which ones are waiting for a table. This visual representation must make it easier to spot potential deadlock situations.
Exactly, Victor. The resource allocation graph is particularly valuable in deadlock detection and prevention strategies. It allows system designers and administrators to quickly identify problematic resource allocation patterns and take appropriate action.
Fascinating stuff, Sheila. As we wrap up, could you give us a quick recap of the key points we've covered about the system model for deadlocks?
Of course, Victor. We've learned that the system model for deadlocks is a simplified representation of processes and resources in an operating system. The model consists of processes, active entities, and resources, passive entities. Resources can be either reusable or consumable. Processes acquire resources before use and release them afterward. Finally, we discussed the resource allocation graph as a tool for visualizing and analyzing resource allocation states in the system.
Excellent summary, Sheila. Understanding this system model is crucial for grasping the concepts of deadlocks that we'll explore in upcoming episodes. Thanks for tuning in, listeners. We hope this episode has given you a solid foundation for understanding deadlocks in operating systems. Until next time, keep your processes running and your resources flowing.